In this video, we're going to look at how we can take the derivative of our inverse trig functions. If you notice here, we have our table of the different inverse trig functions and finding their derivatives. And you're going to find this to hopefully be fairly straightforward as long as you can follow the formula here. And I'm going to look at a couple of them for you. We have the derivative of arc sine of u. Now remember here, u is a differentiable function of x. So the arc sine of u is equal to simply u prime. So you're simply going to take the derivative of u and divide it by the square root of 1 minus u squared. Okay? And then if we look at the derivative of the arc cosine of u, that's going to be the negative, the opposite of u prime. So you can take the derivative of u and then multiply that by negative over the square root of 1 minus u squared. So you can see here, if you can follow the different formulas, it's very straightforward on how to calculate the derivative. So let's look at several examples here. The first one says we want to find the derivative of the arc sine of x squared. So if we're looking at the derivative of our arc sine function, then if we go up here to the top, our arc sine is u prime over the square root of 1 minus u squared. So the formula says we have u prime over the square root of 1 minus u squared. So that simply means here in this case, our u is the x squared. So the derivative of x squared would simply be 2x over the square root of 1 minus u squared. Now be careful, this is u squared, so x squared, that quantity squared would be x to the 4th. And there we have our derivative. Okay, it's that simple. You have to follow the formula. In this case, u prime over the square root of 1 minus u squared. In this problem, our u is equal to x squared. All right, here's another example. We want to find the derivative of the arc secant of 2x. So we need to go to the top. What is the formula for arc secant? Well, arc secant is equal to u prime divided by the absolute value of u multiplied by the square root of u squared minus 1. So we have, once again, u prime over the absolute value of u multiplied by u squared minus 1. So if we're going to find the derivative over here, then our u is simply going to be 2x. So u prime is simply going to be 2. The absolute value of u would be the absolute value of our 2x. And then multiplied by the square root of u squared. Now be careful, it's the whole 2x squared. So 2 squared is 4, and then we have x squared minus 1. And from here we can simplify this a little bit. We have a 2 on top and a 2 on the bottom that would cancel out. So we could write this as 1 over the absolute value of x multiplied by the square root of 4x squared minus 1. And there we have our derivative of our arc secant. All right, here we have our next example. And once again here, maybe try to pause this one and see if you can work this one out on your own. And a little bit of a warning, this is going to be a little bit different because here we have x squared multiplied by the arctangent of x. All right, so hopefully you did try to work this on your own. The arctangent of x, if we go up here, arctangent is u prime over 1 plus u squared. So we have u prime over 1 plus u squared. So if we're going to find the derivative, where do we start? Well, if you notice here, we have x squared multiplied by the arctangent of x. So up here, we're actually going to have to use our product rule, okay, because we're multiplying x squared times the arctangent. So the product rule says that we're going to take our first piece, which is the x squared, and that's going to be multiplied by the derivative of the arctangent. Well, the formula for the arctangent is u prime, so that's going to be 1 over 1 plus u squared, so that's simply x squared. Okay, so there's the first part, and then it's plus the second, which is the arctangent of x, multiplied by the derivative of the first, so that's x squared, so the derivative would simply be 2x. And here we have our derivative. And if we simplify this, we could multiply and we would have x squared over 1 plus x squared plus, now move the 2x in front, 2x times the arctangent of x. And this is our derivative of our function. So be careful. Again, you have to keep in mind all the rules that we've learned in the past. So here, it's not just a straightforward derivative of inverse function, but we had to use the product rule as well. All right, the next example, we have a function of t is equal to sine of arc cosine t. Now this one I'm actually going to work two different ways. First, we're going to work it the way it is, and we're going to calculate the derivative. Sine arc cosine of t. Well, this is going to require us to use the chain rule. So if we first of all start with our sine function. So the derivative of sine would be cosine. So that's the cosine of arc cosine of t. Okay. Then we have to go to the inside, and now we have to take the derivative of the arc cosine of t. Well, if we go up here to the top again, what's the formula for the arc cosine? The arc cosine is negative u prime over the square root of 1 minus u squared. So negative u prime over the square root of 1 minus u squared. So if we take the derivative then, our negative u prime, so that's going to be negative derivative of t is just 1, so that's negative 1 over the square root of 1 minus u squared. Well, our u is the t, so that would simply be t squared. And then our very last would be to take the derivative of our variable t, which in this case the derivative would simply just be 1. Now, if we go back and we do some simplification here, we know that if we take the cosine arc cosine of t, the cosine and inverse cosine, this arc cosine, they're going to cancel out, so we're left with t multiplied by negative 1 over the square root of 1 minus t squared. Or we could think of this as negative t over the square root 1 minus t squared. Okay, so that's one way we can find the derivative. I want to go back now and look at this same problem. So here I want to look at f of t equals the sine arc cosine of t. And I want to show a slightly different way. That we could calculate this problem or find the derivative. If we want to find the derivative here, there's an alternate way, and we could rewrite this using our right triangles, just as we talked about in a previous video with our inverse trig functions. So if I look at drawing a triangle here, we have the arc cosine of t. So if we rewrite this, we can actually eliminate our trig functions and perform this derivative using more of an algebraic expression. So arc cosine of t, well, we know that the cosine is x over r. So we could think of this as t over 1 So then our x is going to be t, our hypotenuse is going to be 1, and then if we want to find the missing side using the Pythagorean theorem, it's the square root of 1 squared, which is 1, minus t squared. So now we're looking at finding the, if we think of this as being our angle, this whole arc cosine of t is our angle theta, and if we want to find the sine of theta, well, the sine of theta is going to be equal to our y, which is the square root of 1 minus t squared, divided by r, which is simply 1. So sine of theta is the square root of 1 minus t squared. So that means that we have f of t, which is equal to sine arc cosine of t, is the same thing as the square root of 1 minus t squared. So if we want to find the derivative, we could rewrite this and think of this as f of t equals 1 minus t squared raised to the 1/2. And if we want to find the derivative, we could use the chain rule. We would take the 1/2 out front, so we'd have 1/2 times 1 minus t squared to the negative 1/2, right? We take 1/2 minus 1, so that's a negative 1/2. Then we take the derivative of the inside, so the derivative of 1 minus t squared would be a negative 2t. And you can say this looks very familiar because once again, what's going to happen? We have a 2 that's going to cancel with the 1/2. And we have a negative t, so that's negative t over this 1 minus t squared. So we could write that as 1 minus t squared to the positive 1/2. And here's our derivative. And if we look above, that's the same thing we had up here. We had negative t over the square root of 1 minus t squared. So we could actually rewrite this in algebraic form, the square root of 1 minus t squared, take the derivative, and we get the same answer, negative t over 1 minus t squared to the 1/2, or you could simply write this as the square root of 1 minus t squared. All right, one last example. And this one's a little bit different. It says, find an equation of the tangent line to the graph of the function at the given point. Now, I know we've done this before. I know it's maybe been a while, but how do we find the graph? How do we find an equation of the tangent line to the graph of the function at the given point? Well, we know that if we're trying to find an equation, we need to know a point, which is given. We have the point, negative square root of 2 over 2 and 3 pi over 8. But we also need to know the slope. Well, if we have this function and we're looking for that tangent line, then we know that we can find the derivative because our derivative is the rate of change, or the derivative is our slope. So here we need to first start by taking the derivative of our function. So we would have 1/2 is just a common multiplier. And then we have arc cosine of x. Well, if we go back and look, what is the formula for the arc cosine of x? And if we look up here, the arc cosine is negative u prime over the square root of 1 minus u squared. So we have negative u prime over the square root of 1 minus u squared. So the derivative of arc cosine then is simply going to be derivative of x, that's 1, so that would be negative 1 over the square root of 1 minus x squared. And we could simplify this and go ahead and multiply the 1/2, so we would still have negative 1 over 2 times the square root of 1 minus x squared. And now we want to evaluate this at our given point. So if we look at our point, negative square root of 2 over 2 and 3 pi over 8, we're going to end up with y prime equals negative 1 over 2 times the square root of 1 minus x squared. Well, our x is a negative square root of 2 over 2. Well, if we square this, the negative is going to become positive. We square the square root, so that's going to be 2. We square the 2 on the bottom, that's a 4. So we're going to end up with a positive 2/4, or simply 1/2. All right, and then if we simplify this further, we're going to end up with 1 minus a half, which is 1/2. Okay, so 1 minus, so we have the square root of 1/2. So we'd have the square root of 1 over 2. So the square root of 1 is simply 1. And then we're left with the square root of 2. So we have 1 over the square root of 2. And if we divide this, then here what happens? Well, we can multiply by the reciprocal. Okay, so if we multiply by the reciprocal, that means we're going to take this negative 1/2 and multiply by the square root of 2 over 1. So we really, the ones cancel, and we're left with negative square root of 2 over 2. And this right here, this is going to be our slope. So now we're going to use this slope, and we'll go back up here. Our slope here is negative square root of 2 over 2. Okay, so here's our slope. And we have our point, negative square root of 2 over 2 and 3 pi over 8. So if we want to find the equation of that tangent line, we can use several different ways. We could use the slope-intercept form, or we could use the point slope, which is y minus y1 equals m, which is our slope, times x minus x1. So we could plug in and we get y minus y1. Well, that would be 3 pi over 8 equals our slope, negative square root of 2 over 2, times x minus, now notice here it's x minus a negative square root of 2, so that's going to make it positive square root of 2 over 2. And here we have the equation of our tangent line. And from here we can simplify. We can distribute, and we would have negative square root of 2 over 2 times x minus, well, if we multiply here, square root of 2, that's going to be simply 2 over 4. Well, 2 over 4, that would simplify to 1/2. And a negative and a positive makes this negative. So then if we move over the negative 3 pi over 8, we have a negative square root of 2 over 2 x minus 1/2 plus 3 pi over 8. So here's the equation of our tangent line at the given point, negative square root of 2 over 2, 3 pi over 8.